Hello everyone, in this video clip, I'm going to share with you how to solve this coordinate geometry question. Now let's understand the information given in the question. Diagram 1 shows a quadrilateral KLMN. KLMN. And given that the coordinates of M is negative PP, where P greater than 0, and the length of MN, M to N is square root of 72, and O is the midpoint of MN. So, okay, we have a few information here. First thing, we know that the equation of MN, okay, the equation of MN is actually y equals to negative x. Now, how do I know? Because of the coordinates of M. Okay, so when x is P, y is negative x, positive P. So this is how we got, yeah? After all, if this is negative P, the base distance is P, and the height, the y coordinates is P, therefore the height of this triangle is P. So let me just get that triangle out. Okay, this is the origin, and this is point M. So we know that, and this is 90 degrees, yeah? So we know that the length of the base and the height is P, and the distance of MN is 72, therefore MO will be half of square root of 72. So we use the Pythagoras Theorem to find P. So 2P squared, because P squared plus P squared equals to the square of half 72 square root of 72. So 2P squared goes to 1 over 4 times with 72. And therefore P squared equals to 72 over 4 over 2, which is 8. So we got 9 here. So P equals to, by right, when we bring our own square across to the other side of the equation, we have to put plus minus in front. But this one we just put positive square root of 9 because it says P greater than 0. So P is just positive, no negative. So we got P equals to 3. So if that's the way, okay, we found P is 3, therefore the coordinates of M will be negative 3 and 3. So with that, the coordinates of N, because it's at the same distance apart, so 3 units, so we have the coordinates of N, 3 and negative 3. Okay? Now, next, we need to find the coordinates of L, given that the equation of KL is here, y plus x equals to 8. Now, this is a general form. Let's change it to the gradient form so that it gives us more information about the gradient and the y-intercept. Okay, so we have negative x plus 8. So according to y equals to mx plus c, we compare, we notice that our gradient is negative 1 and the y-intercept is 8. Okay, so if m is negative 1, therefore this is 90 degrees. Okay, therefore we can form the equation of ML first. Okay, because of the 90 degree there. So we know that the gradient of ML multiply the gradient of MN equals to negative 1 because they are perpendicular to each other. So how do I find the gradient of ML? We take y minus the y value of our M. Yeah. Okay, so y minus 3 over x minus negative 3, so it becomes plus 3, times the gradient of mn is negative 1. Now we know that it's a negative 1 because after all, p over p is 1. And because it's going downhill, so it's negative 1. So times with negative 1 equals to negative 1. Therefore, y minus 3 over x plus 3 will be just 1 because you bring the negative 1 over, so it cancels off the negative value on the other side. So y equals to x plus 3. Okay, and y equals to x plus 3 become plus 6. So this is equation of ML. And compare with the equation of KL, which is y equals to negative x plus 8. All right, so you notice that the L is actually the common point of intersection. So we solve these two equations simultaneously. We can find the coordinates of L. So at L, okay, equation 1 equals to equation 2. So x plus 6 equals to negative x plus 8. Rearrange the equation, minus x go there, become plus x, so we got 2x. 8, bring the plus 6 over, become minus 6. So 8 minus 6, we got 2. So x equals to 1. And from either equation 1 or 2, whichever you like, y equals to 1 plus 6. 1 plus 6, therefore it's 7. So we found the coordinates of L to be 1, 7. Got it. Okay, 1, 7. And next, we need to find the equation of Kn. Now, to find the equation of Kn, all right, in order for us to find the equation, this is B part 2. You want to find the equation of Kn, you must have two things. One is the gradient of Kn. Another one is the point on Kn. In this case, we know the point n, which is 3 and negative 3. Okay, but what is the gradient of Kn? This one. I don't know, unless I can find the coordinates of K. So by looking at this diagram, okay, and because this one is parallel, because this is a trapezium, trapezium, it's parallel. Because you see your m is negative 1 for the gradient of KL, and the gradient of mn is also negative 1. So they are parallel. If this is 90 degrees, so the distance must be the same. That means you have the same gradient here. Okay, the same gradient here. So the gradient of ML and the gradient of OK is the same. The gradient of ML is the same as the gradient of OK. How do we find the gradient of OK? So y over x, because the origin is 0. And how do we find the gradient of ML? ML is, where's M and where's L? Okay, we have the coordinates of M and L, yeah? So we take 7 minus 3. The x will be 1 minus negative 3, so plus 3. So we have y over x equals to 4 over 4. So in this case, the coordinates of k will be 4, 4. So once we found the coordinates of k, then we can find the gradient of kn. The gradient of kn will be, we take the y2 minus y1, so 4 minus negative 3, so become plus 3. And then x minus x, so 4 minus 3. So we have 7. So the gradient of the kn is 7. So now we substitute into y minus y1 equals to gradient x minus x1. This is the formula. Once you have the m, you have the n, you got to substitute into this to find the equation of straight line. Okay, this is the way we find the equation of straight line. So y minus y1. So y, generally y minus the y1 here. So become plus 3 equals to m is 7, x minus x1, which is 3. Okay, so we have 7x minus 21, and then minus 3 to get y. So we will have the equation of kn to be 7x minus 24. That's it. Okay, so if you have any other question, please leave your question in the comment area. I'll come back to you as soon as I can. Thank you very much.